All right, Chapter 1, Section 1, Graphing Linear Equations in Two Variables. We're going to start with a definition. A linear equation in two variables is an equation that can be written in the form ax plus by, where a, b, and c are real numbers. This form of an equation is called standard form. A few things I want to call out. X and y are variables. A, b, and c are any real number. Okay, let me give you some examples so that you can look at of linear equations in two variables. A linear equation in two variables could be 2x plus y is equal to 8. You can see here that my coefficients, a would be 2, b would be 1, which is assumed to be in front of y here, and c would be 8. 2 is a, which is the coefficient of x, and 1 would be b, the coefficient of y, and 8 would be the constant term c in this equation. 2x plus 1y is equal to 8. This is a linear equation in two variables. Let me give you some more examples. X is equal to 3 is actually a linear equation in two variables. One might think it's not because it's missing the y term, but this equation can be rewritten to mean x plus 0y is equal to 3. After all, 0 times y is 0, and x plus 0 is just x. So this equation, x equal to 3, although you don't see a y variable, you can rewrite it with x plus 0y equal to 3. So it is a linear equation in two variables. As is, let's see, y is equal to 4. That's a linear equation in two variables because you can rewrite that as 0x plus 1y is equal to 4, right? Let me give you just a couple more linear equations in two variables here. 1/3 x minus 0.2y is equal to 2/7, right? So you can definitely have fractions in your equation. These fractions are the coefficients. So 1/3 is the coefficient of x, negative 0.2 is the coefficient of y, and 2/7 is your constant term. Let me give us one more, okay? Y is equal to 2/3 x minus 5. This is a linear equation in two variables. Now, this equation is not written in standard form because standard form, let me scroll back up on the screen here. Standard form means your variables are on the same side, right? The variables are on the same side and your constant term is on the other. Look at this equation is in standard form. Your variables are on the same side, your constant term is on the other. This equation, however, is not written in standard form because x and y are not on the same side. In a few minutes, we'll call this form actually slope-intercept form. When y is isolated, we call it slope-intercept form, also known as y equals mx plus b form. All right, so I've given you a few examples of linear equations in two variables, all right? What I would really like you to take note of is the power that's on x, the variable x, and the power that's on y. Or I can say it like this, the exponent that is on the variable x and the exponent that's on the variable y. Now, somebody may say, well, there is no exponent on x and there is no exponent on y, but really, when there is no exponent written, it's assumed to be 1. Same thing for the variable y. They both have exponents of 1. So when you have a linear equation in two variables, basically it's meaning that the exponent on your variables x and y are 1. This is what we would call first degree. Okay, the power on your variable is 1. So what we're going to do in this section is we're going to graph linear equations in two variables. Now the graph of any linear equation will be a line. You could even see the word line in the word linear, right? So if you have a linear equation, when you graph it, it'll be a line. So we're going to be graphing lines in this section. Now there are many ways you can graph a line, so let me walk you through it. Let's look at our first example. So this equation says, or this example, says find two ordered pairs for 2x plus 4y equal to 12. In other words, they want you to find an x and a y x and y values such that when you substitute them in for x and y, you get 12. 2 times some number plus 4 times some other number equals 12. Find an ordered pair. Now, there's going to be two different methods. So the first method I want to walk you through is you and I just plugging in a random value for either one of the variables. So I'm going to pick something at random, okay? So I'm going to say let x equal, I don't know, let's just say, let's plug in 2. And if we plug in 2 for the variable x, we would get the following. 2 times 2 plus 4y is equal to 12. 2 times 2 is 4, so we'd have 4 plus 4y is equal to 12. When I subtract 4 from both sides, let me show you that here real quick. Subtract this 4 from both sides. I end up with simply 4y is equal to 8. And then finally, we can divide both sides by 4, and we get that when x is 2, y is 2. So an ordered pair that will satisfy this equation is 2, 2. This is an ordered pair. Just want to remind you that when you have an ordered pair, the first coordinate is x, the second coordinate is y. So this is an ordered pair that satisfies this equation. Okay, now let's keep in mind that there are infinitely many solutions to this example. You didn't have to plug in 2 for x. You could have plugged in 1 for x, or 3 for x, or 4 for x, or whatever other number you want for x. Or, you know what? You could have even plugged something in for y and then found x, right? So you don't have to start with plugging in for x. You can plug something in for y. So there's many different things you could do. Here's just one example. Now, they said find 2 ordered pairs. We just found 1 so far. So let's now go find another one. What if this time we say let, how about let y be -2? How about that? Let's plug in -2 for y. What would happen? Let's see. 2 times x plus 4 times -2 is equal to 12. Then we would have 2x minus 8 is equal to 12. So when we solve for x, when we isolate x, we're going to add 8 to both sides, like that. And we're going to end up having 2x is equal to 20, right? And so then when we divide both sides by 2, you and I find that x is equal to 10. So then the ordered pair here is x is 10 and y was -2. That's another ordered pair for this equation. And again, just remember there's infinitely many, all right? So you can go and find your some different ones if you want, but I found 10, -2. All right, now let's go to method number 2. Now method number 2 has us using, has us finding special points, okay? Not just random points like you and I did in method number 1. Method number 2 has us finding a special point called the x-intercept and another special point called the y-intercept, okay? Now, before I go find these points, let me be very clear about what an x-intercept and y-intercept are. Here's a picture to understand, help us understand what an x-intercept is and a y-intercept. This is just a random line that I just drew right now, and I'm locating 2 special points here. This is called the x-intercept here, and then this is called the y-intercept here. So the x-intercept is the point at which the line crosses the x-axis, and the y-intercept is the point at which the line crosses the y-axis. Remember that all along the x-axis here, your y value is 0. So the way you and I will find an x-intercept is by plugging in 0 for y. For a y-intercept, all along the y-axis, your x value is 0. So the way we're going to find a y-intercept is by plugging in 0 for x, all right? All right, so let's find the x-intercept. We're going to substitute 0 for y. So it'll be 2x plus 4 times 0 is equal to 12. That's 2x plus 0 is equal to 12, or just 2x is equal to 12. When you divide both sides by 2, you get x equal to 6. So then the ordered pair, the x-intercept, is 6, comma 0. That's the x-intercept. Now what we can do is find the y-intercept. This time to find the y-intercept, we'll substitute 0 for x and then solve for y. So 2 times 0 plus 4y is equal to 12. That's the same thing as saying 0 plus 4y is 12. Or simply 4y is 12. When you divide both sides by 4, 12 divided by 4 is 3. So then the y-intercept is 0, comma 3. Next example, find the x and y-intercept for 3x minus 4y is equal to 0. All right, notice that this equation is set equal to 0. It's in standard form, and it's set equal to 0. Let's find the x-intercept. You find the x-intercept by plugging in 0 for y. That would leave you with 3x minus 0 is equal to 0. That is to say, 3x is equal to 0. When you divide both sides by 3, you get 0 divided by 3, which is 0. So 0, comma 0 is the x-intercept, which happens to be the origin, right? The origin in our plane, in our Cartesian x and y coordinate plane. Let us now find the y-intercept. You find the y-intercept by plugging in 0 for x. And you'll get 0 minus 4y is equal to 0, which is negative 4y equal to 0. When you divide both sides by negative 4, you get y is equal to 0 divided by negative 4, which is still just 0. So your ordered pair is 0, comma 0. So the origin is both the x-intercept and the y-intercept in for this equation. So what I want to point out to you guys here is that whenever you have an equation that is set equal to 0, you can guarantee right away whenever you have an equation in two variables set equal to 0, you know the origin will be both the x-intercept and the y-intercept. Now this brings up an important point, when graphing lines. When you graph lines, all you really need to graph a line are two different points. That's all you need to graph a line. So finding the x and y intercepts is great, but sometimes the x and y intercept are the same point. So if you were to graph this line using the method of finding the intercepts, you only have one point so far because the intercepts are the same. In other words, you would have to go find an additional point. So the only limitation, really the only limitation when you're using the method of intercepts to graphing a line is the case in which the intercepts are the same, namely the origin. If the line goes right through the origin, you're only going to get one intercept. The x and y intercepts are going to be the same point, so you're going to need an additional point. This leads us to check this out. Graph the line through the point negative 3, 2 with slope m equal to negative 4/3. A few things about slope. We always use the letter m to denote slope. Another thing is this slope is negative. Now, the slope of a line describes the steepness of the line. The slope of a line describes the steepness of the line. Many people know slope as rise over run, or vertical change over horizontal change. So it's describing how you're moving from one point on the line to another. So let's see how this works out. Let's draw the Cartesian plane, or the x and y coordinate plane. Okay, so I drew my Cartesian plane. The first thing I would like to do is plot this point, negative 3, positive 2. So x is negative and your y value is positive. That means you are in quadrant number 2. This is the area where your x values are negative and your y values are positive. So negative 3 on the x-axis, negative 3 is here, and positive 2 is here. So negative 3, positive 2 is here. Negative 3, positive 2, about right there. That's where I'll start with my line. The next thing I'll do is I'll apply the slope. Now the slope is negative 4 over 3. Remember that the slope is rise over run. So if you write the slope, now this is a confusing part for some people. The negative here can be given to the rise or it can be given to the run. It doesn't matter. If it's given to the rise, then this would mean that you would go down 4 units and then you would go to the right 3 units because you have something negative over something positive. If you write it with the negative in the denominator, part of the run, well, that would mean your rise is positive, so you would go up 4 and then to the left by 3. So it doesn't matter which slope you apply. It just, do whatever you'd like. Now, when I think about how I scaled my axes, I can tell that, if I use this version of the slope, going up 4 to the left by 3, that's fine. But if I go up 4, 1, 2, 3, 4, it's going to get a little messy because I didn't go that high on my y-axis. I guess I could redraw my graph, but I don't want to do that. So I'm going to just go with this version. I'm going to go down 4 units, right? And then to the left by 3. So let me show you this version of my slope, okay, everybody? And I'm only doing that just because of how I drew my picture. I don't really have room to go up 4 right now, all right? So I'm going to go down 4 units and then to the left by 3. Now, if I'm at negative 3, positive 2, right? Negative 3, positive 2. If I go down 4 units, 1, 2, 3, and 4, I'm down here. Let me show you that. Down 4 units would put you at about right there, right? And then don't plot a point yet because you got to go down 4 units and then you have to go to the right by 3. 1, 2, 3. And that would be the point there, right on the y-axis. Okay, that would be right on the y-axis. So now that you have 2 points, you can definitely draw your line through the 2 points. Always with arrowheads on the end of the line, showing that your line goes indefinitely in both directions. This is method number 3. I guess I never wrote that down anywhere, so let me write that down. This is method 3 using slope. This is method 3 for graphing a line, using slope to graph a line. I want you to notice something. I want you to draw this connection. The slope was negative and your line is going down from left to right. Your slope is negative and your line is going down from left to right. That's always true. Whenever the slope is negative, the line will be going down from left to right. If the slope were positive, the line would be going up from left to right. Okay? Check out example 4. Graph the line through the point 1, negative 2 with slope, or m, equal to 4. Now, let's start with 1, negative 2. Because your x value is positive and your y value is negative, that puts us in quadrant number 4. All right, let's do it. The first thing I'll do is plot the point 1, negative 2. There it is right there. Now, I have to move from this point according to my slope, but I want to draw your attention to this slope, m equal to 4. There's a lot of different ways for you to write the ratio of 4, the fraction 4. You can write it as, I think most people would probably write it, 4 over 1, or you can write it as, so I don't know, there's infinitely many ways. How about 8 over 2? That's 4. How about negative 16 over negative 4? That's also positive 4. How about this one? How about negative 4 over negative 1? All of these ratios or fractions are equal to 4. So it's really up to you how you want to express your slope. I think most people would probably just simply put 4 over 1. But please keep in mind there are many different ways to write the number 4. Okay, so if we use 4 over 1, that means I'm going to go up 4 units, right? This means up 4 units and then to the right by 1 unit. So up 4 units, 1, 2, 3, 4, and then to the right by 1 would drop me off at the point 2, comma 2. Now that I have 2 points, I can draw the line through my 2 points with arrowheads. Now remember, you can use the slope again, go up 4 units again and to the right by 1 from your brand new point, and then you would get another point way up here somewhere, which also lies on the line. Notice that your slope was positive, and look at your line. Your line is going up from left to right. Now, the next important concept is something called slope-intercept form of a line. I mentioned it earlier. It's y equals mx plus b. Notice that whenever you have y isolated, that is slope-intercept form of a line. Some important features about this form, I'll call them out for you now. The coefficient of x is the slope. Whatever number is attached, if you will, to x is your slope. And b is the y-coordinate of your y-intercept, okay? So whenever the equation is written in slope-intercept form, it's basically giving you two important features of the graph. A point, right? The y-intercept is a point on the line, and it's giving you the slope. Let's check out this example. Graph y equal to 1/3 x minus 2 using the slope and the y-intercept. Now, I want you to keep in mind this equation that they've given you is in slope-intercept form. We know that because y is isolated. Another thing I want you to notice is that your slope is 1/3 and your y-intercept is -2. Let's jot that down, okay? So your slope is positive 1/3. Now remember that because the slope is positive, the line's going to be going up from left to right. And then your y-intercept is, let's write it in ordered pair form, 0, -2. So what I'll do is I'll graph this line starting with the y-intercept, right? I'll plot that point, and then I'll move from that point according to my slope. Now, the slope is rise over run, and because the slope is positive, the rise and the run are positive, so it's up 1 and to the right by 3, okay? Okay, so let me start by plotting my y-intercept. There it is. And then I'm going to go up 1 unit, and then to the right by 1, 2, 3. That drops me off right here at 3, -1. So I'll go ahead and plot that point there, right there. And I'll draw the line through my 2 points with some arrowheads like that. So there is the graph of the equation. Now, remember that we said in the very beginning that since the slope is positive, the line should be going up. And guess what? It is going up. Good job. Now, the next example is, has the same instructions. Graph this line, 2x plus y is equal to -1, using the slope and y-intercept. The problem here is this line is not yet in slope-intercept form. In order to get it in slope-intercept form, we have to solve for y, or isolate y, okay? So let's isolate y. The way I'm going to do that is just by subtracting 2x from both sides. So subtract 2x from that side and from that side. If you write this equation in slope-intercept form, it'll be y is equal to -2x minus 1. So this is slope-intercept form right here. The slope is -2. And if you don't mind, I'll write it as -2 over +1. We did say in the previous example that there are many different ways to write the slope as -2, but I'll write it as -2 over +1. And then your y-intercept, we'll write this as an ordered pair, is 0, -1. So what we'll do is we'll start with -1, the y-intercept, and then we'll move according to our slope. All right, so we'll plot the y-intercept first, and then now I'm supposed to move according to my slope. Now the slope I chose to write was -2 over 1, which means down by 2 units, and then to the right by 1. So then when I move from my y-intercept down 2 units, this is down 2 units, and then to the right by 1, drops me off at 1, -3. So I'll go ahead and plot that point. And then I'll draw the line through my 2 points. Notice that the line is going down from left to right, And that makes sense because my slope is negative. Cool deal. All right, we have a brand new equation, 2x plus 4y is equal to 12. And what we want to do is use a slope-intercept form in order of this line or this equation to use the slope and y-intercept, all right? So what we'll do is we'll start with the equation, 2x plus 4y is 12. And in order to write this in slope-intercept form, we're going to want to isolate y, which means we're going to want to subtract 2x from both sides. That would leave us with 4y is equal to negative 2x plus 12. Then we want to divide every term by 4. That would leave us with y isolated. So now this is slope-intercept form. And negative 2 over 4 should be simplified to negative 1/2. And then 12 divided by 4 is 3. So this, ladies and gentlemen, is your slope-intercept form. So you can see now, hopefully, that your slope is negative, and it's negative 1 over 2. Notice I gave the negative to the 1 instead of the 2. It doesn't matter. Remember, you can give the negative to either the numerator or the denominator, either the rise or the run. It's completely up to you. The y-intercept is 0, 3. I always like to write it in ordered pair form. So you know what we're going to do. We're going to start with the y-intercept, and then we'll move according to our slope. I invite you to pause this video and do that now. Go ahead with me and do that on your own. Graph this line, starting with the y-intercept, and then apply the slope. All right, I hope this is the line that you graphed. Started with the y-intercept, and then I went down 1 unit and then to the right by 2 units. And it dropped me off at this point, which is 2, 2. All right. You know what I didn't say in the beginning? I should have said, but it's not too late for me to encourage you to do this. To graph, whenever you're graphing, use graph paper. Instead of line paper or blank paper, use graph paper. It'll make your graphing a lot more efficient. All right, check out this example. Graph 3x minus 2y equal to 0 using the slope and y-intercept. All right, so let's do this. Let's start with this line, and let's solve for y. So when we solve for y here, we're going to subtract 3x from both sides, okay? And that would leave us with just negative 2y is equal to negative 3x. And then what we'll do next is divide every term by negative 2. And that would leave us with slope-intercept form of y is equal to positive 3/2 times x. Notice that the constant term is missing here. It's not here. So if you want, you could put, if you really wanted to, you can write in plus 0 if you want. Okay, that's up to you though. You don't have to. So y equal to 3/2 x is slope-intercept form. If you want to plug in, or not plug in, but if you want to write it as plus 0, that's fine. Okay. At the end of the day, it's important that you and I understand that my slope is 3/2, positive 3/2, and my y-intercept is 0. Okay. So this graph is going right through the origin with positive 3/2 as the slope, okay? So let's do that really quickly. Okay, scale out my axes a little bit. All right, so here is my y and basically my x-intercept and my y-intercept. I want to go up 3 units, 1, 2, 3, and then to the right by 2. Okay, that would drop me off at the point 2, 3, and I want to draw the line through these 2 points, and then always use arrowheads, remember, and this line is going up. That agrees with the algebra because my slope is positive. Okay, to wrap up this lesson, We're going to focus on graphing horizontal and vertical lines, okay? What we've done, examples 1 through 8, is we were graphing diagonal lines. Now we're going to be talking about horizontal and vertical lines. This equation says y equal to 3. So this is what I want you to focus on, is that this equation here, if you want to write it in slope-intercept form, you can. It would be written as y equals 0x plus 3. Because after all, 0 times x is 0, and 0 plus 3 is 3. So this is y equal to 3. Okay? So in other words, no matter what you plug in for x, it will be multiplied by 0, so it's going to go away, and then you'll end up with y equal to 3 every single time. For example, let x be, I'm just going to choose something, okay? Let x be 1. Then you would get y is equal to 0 times 1 plus 3, which is just equal to 3, right? Because 0 times 1 is 0, and 0 plus 3 is 3. So in other words, this ordered pair is 1, comma 3. Now watch this. Let x be 2. You're going to end up with the same outcome every single time. When x is 2, you'll have 0 times 2 plus 3, which is, again, 3, because 0 times 2 is 0, and 0 plus 3 is 3. So then the ordered pair is 2, comma 3. No matter what you choose for x, y will always be 3. Also notice that your slope is 0. All right, so let's graph this. 1, 3, and 2, 3. All right, cool. Scaling my axes here. All right, cool. So let's plot these 2 points, 1, 3 and 2, 3, and draw the line. And I could have kept going, right? I just generated 2 points, though. When you draw the line through these two, you have a horizontal line. Okay, this is a horizontal line. So I want to draw a few observations about horizontal lines now for you. Number 1, if the slope is 0, the line is horizontal. In other words, any horizontal line or all horizontal lines have slope of 0. Number 2, all the equations for horizontal lines look the same, y equal to a number. So please add this to your notes, okay? Whenever the slope is 0, you know we're talking about a horizontal line. If I say we have a horizontal line, then you can automatically guarantee the slope will be 0. Another thing is the equation always looks like this, y equal to a number. There's no x variable, it's just y equal to 3, or y equal to 4, or y equal to -7, or whatever. Y equal to some number, that's going to be the equation for a horizontal line. Let's talk about a vertical line to wrap this up. Last example, graph x equal to -2. All right. Now, no matter what you plug in for y, x will always be -2. If you wanted to write this in standard form, you could. You could write this as 0, you can write this as x plus 0y is equal to -2, right? Because after all, 0 times y is 0, and 0 plus x is x, so x is equal to -2, all right? So in other words, no matter what you choose for y, x will always be -2. So let's play around with this for a little bit. Let y be 1. If y is 1, I'm going to show you that x will still be just -2. So x plus 0 times 1 is -2, which would leave you with just x is equal to -2, because 0 times 1 is 0, so that goes away. So then the ordered pair here would be -2, comma 1. Let's play around with this just one more time. Let y be 3. I don't know, I'm just choosing that at random. So then you would have x plus 0 times 3 is equal to -2. And that would mean that x is equal to negative 2 because 0 times 3 is 0 and 0 plus x is x. So it says x is just negative 2 again. So then the ordered pair here is negative 2, 3. So let's go to the Cartesian plane and graph this line. So let's get this plane going here. Yeah. Okay, just scale this out a little bit. Thanks for being patient. Okay, cool. So let's plot these 2 points that you and I generated, negative 2, positive 1, and negative 2, positive 3. So you can see that when you draw the line through these two ordered pairs that you and I generated, you get a vertical line, straight up and down, all right? Okay, guys, the couple observations I want us to make about vertical lines are the following. Number one, the slope is always undefined. The slope of any vertical line is always undefined. In order to prove that for you, I'll probably do that in a later section when we talk about the slope formula, but I will eventually prove to you that the slope of any vertical line is always undefined. And then the equation for any vertical line looks the same. It's always x equal to a number. Like in our case, for this example, it was x equal to negative 2. But it could be like x equal to 5 or x equal to 7 or whatever. So as long as you have an equation that is of the form x equal to a number, it is the equation for a vertical line. So please contrast this to the information I gave you for horizontal lines, okay? All right, everybody, we covered a lot in this very first section. We talked about how to graph a line 3 different ways, 3 different methods. Method number 1 was choosing random values to plug in for x or for y, solve for the other variable. And that was just generating ordered pairs, right? Method number 2 was finding the x and y intercept for a line. And then you can use those two intercepts to graph the line. The only limitation for that method of finding intercepts is when the intercepts were the same, were 0, 0, right? And then method number 3 is slope-intercept form, y equals mx plus b form, using a point, which is the y-intercept, and the slope to graph your line. And then finally, we talked about horizontal and vertical lines. Horizontal lines have slope 0, and equations that are of the form y equal to a number. A vertical line, the slope is undefined and have equations of the form x equal to a number. All right, I hope you learned a lot. I hope this was very clear. I'll catch you in the next lesson. See you later.